Question 6. This is about supply and demand. So in this question we are given the following system. So we know that the supply function of price is given by 15p minus 100, and the demand function of price is equal to minus 5p plus 100, and that's a little coupled system here. Question A asks us to find the equilibrium price and the corresponding quantity of the commodity at equilibrium. Okay, now equilibrium price is denoted by P bar, and it satisfies the equation QS at P bar, and we typically also denote with a little bar above the QS to denote we've got an equilibrium supply number, and similarly QD with a little bar upon it is equal to P bar. Now in order to reduce this to something that we can solve, we just need to input what QS at P bar is. So reading from above in equation 1, that's 15p bar minus 100, and QD at P bar is minus 5p bar plus 100. If we process this equation line, we can simplify it. We get 20p bar is equal to 200, and that simply tells us that P bar is equal to 10. So 10 is the equilibrium price, and in this particular question the equilibrium price is in pounds sterling, so the equilibrium price is £10 sterling. The corresponding equilibrium commodity value can be achieved by putting this equilibrium price back into either of the two equations with which we began. So in this particular case we would have the corresponding equilibrium quantity of the commodity. Equilibrium quantity is, and we can take either of the two equations. Let's just take the first one, 15 times P bar, which is 10 minus 100, that's simply equal to 150 minus 100, which is otherwise known as 50. And we could, for instance, say units afterwards. Units of something, we don't really know what it is in this question, but 50 it is. Okay, question B, or part B rather. We're asked to rearrange the equations for above for P in terms of QS and P in terms of QD. Let's just do that for the moment. So we'll start with the first one. QS is equal to 15p minus 100. We'll rearrange to isolate 15p on one side. That will give us 15p is equal to QS plus 100, and then we'll divide both sides throughout by 15. That will give us 115 QS plus 100 over 15. But if you think a little and simplify that, you'll notice there are a common factor of a 5 on top and bottom. That will simply reduce to 20 upon 3. Okay, maybe just alongside, I'll put a little vertical line to separate out the supply calculations from the demand calculations. Let's begin with QD. The other equation is equal to minus 5p plus 100. Rearranging this for p on one side, we get 5p is equal to negative QD plus 100. And then p is equal to minus 1/5 QD plus, and then in this case 100 upon 5 is simply known as 20. So there we have the two equations in rearranged form. In order to write down the corresponding inverse supply and demand functions, I would use the following notation. Thus, PS of Q is equal to 1/15 Q plus 20 upon 3, and PD of Q is equal to minus 1/5 Q plus 20. And really at this point you'll notice that I've not introduced any new calculations or done any new mathematics. All I've done is relabel the equations above, separated by that little line, using, for instance, P sub S instead of P in the first equation, and then removing the S from the Q. Okay, this gives us a new little system of equations to study, and that's what we're asked to do in part C. So we're asked to solve the system of simultaneous linear equations. And I'll write this in a way that makes it slightly clearer what's going on. So I'll rewrite just now P is equal to 1/5 Q plus 20 upon 3, and P is equal to minus 1/5 Q plus 20. I know we're using a new notation at this moment, but really what we're doing is writing this out in a form with which we're more used to deal. Usually it's y would be equal to 1/15 x plus 20 upon 3, or y is equal to negative 1/5 x plus 20. But in this question we have P and Q for supply and demand, so all we're doing is switching out y's for q's, or really in this case y's for p's, and x's for q's. Okay, we have a system of simultaneous equations. Let's solve them and see if the corresponding solution is exactly the same as the equilibrium solution we found from part 6a. Okay, I will label the first equation 1, the second equation 2. The simplest thing to do, I would argue here, is to, well, it's not necessarily the simplest, but it's the method that I like. What I'll do is I'll take 15 times equation 1 and subtract off 5, or rather add 5 times equation 2. And this will yield the following. So 15 times 1 on the left hand side is 15p, plus 5 times 2 on the left hand side is 5 times p. That is equal to 15 into 1 upon 15 q plus 20 upon 3, plus 5 into minus 1 upon 5q plus 20. What I'm going to do is process the information there. We get 20p is equal to q plus 100 minus q plus 100. Therefore 20p is equal to 200, and so p is equal to 10 as before. Right, now in order to find the corresponding equilibrium value of, or rather the corresponding value of q in the system of simultaneous equations, we will input p equals 10 into either one of these and see where we get. Okay, so let's work with the second equation here. So the second equation will yield 10 is equal to minus 1/5 q plus, and let's just check what that value was, that was 20. Multiplying both sides by, let's say 5, we yield 50 is equal to minus q plus 100. Therefore q is equal to 50. And as we'll note from above, these are precisely the same values that we achieved when originally solving for the equilibrium value of price and commodity value in part A. And that's the question done.